Is it true is a routine where students are shown a statement comparing fractions. And the first step is for them to make a prediction without calculating, without models, as to whether that statement is true or false. And then once they've made their decision, we start to build a model of the statement to actually determine whether it's true or false. So here's the statement. So in your kit right here, you have a true card and a false card. So what I want you to do is hold up your prediction. Okay, now we're not going to explain your reasons yet, but what you're going to do is you're going to put your card right down on your whiteboard and use your fraction tiles right here to build this statement on the table. All right, so everyone has built their model, and you can switch out your card if you think that you'd like to change your prediction. So if you think it's false, keep it false. If you think it's true, keep it true. But if you want to change it, you can change it. Okay. Here is the next step of the activity. You're going to show and explain your thinking. You're going to use a sentence frame, and this sentence frame says, the statement is, you fill in the blank with true or false, and then say because, and you'll give your reasoning. When you use your reasoning, you're going to do your best to use some fraction vocabulary words, okay?
I think the statement is false because 3/5 is greater, 3/5 is greater than 3/8, and because 3/5 is closer to 1/2.
So when you say that 3/5 is larger or greater than 3/8, how can you use your model to explain that?
So here, the green one is 1/5, and there are 3/5, and it's bigger here, and 3/8 is smaller here.
Okay.
I think this statement is false because 3/5 is greater than 3/8 because if you add like 2 more fifths, it will be a whole. But if you add like 5/5, it will be a whole of 8/8. But like the numerator is much more closer than the denominator.
So, yeah, okay. So the numerator is closer to what than the denominator?
Like 3/5, if you add like 2
Okay.
more fifths, it will equals 1 whole.
Okay. And what are your thoughts? How can you explain?
I think the statement is false because the 1/5 compared to the 3/5 compared to the 3/8, the 3/5 are like they're over than 3/8.
Okay. What do you mean they're over than 3/8? What are you?
They're larger.
Okay.
'Cause, they have less piece. Yeah, they have less pieces, and the 3/8 has more pieces.
I'm curious because you actually have 3 pieces of fifths and 3 pieces of eighths. So tell me what you were thinking when you were comparing 3/8 to 3/5. You talked about the size of the fraction, I think.
Because 3/8, you need 5 more to get to 1 whole, and only 2 more to get to over 1/5.
Connecting the numeric representation together with the fraction tiles is a very important piece of their understanding of fractions. And they can therefore start determining that when there are a lot of pieces in a whole, then the size of those pieces is smaller. The next part of this activity is called Make It True. What I'm going to ask you to do is to write false right up here instead of using the card. Slide your model off so that the bottom part of your whiteboard can be used to make it true. But there's something we need to change to make the statement true. What's one way you could make it true? Who has a thought? Yes.
By switching this around and making the so like this.
Okay, show me. Oh. Okay. So I'm noticing that you switched and put 3/5 first, and you kept the same symbol, greater than, and then put the 3/8 last. Is there a different way? That's one way. There's another way you could do it. What's your idea?
I think you could do like this. Put 3/8 less than.
Ooh, could I borrow your whiteboard? Okay. Here's what he did. He kept the same order, right? But what did you change?
The symbol.
He changed the symbol. And what did he notice? Now, how does this read? How does this read? Can you read this for us? What does it say?
3/8 is less than 3/5.
Okay. We have now built models, and we all agree that this is false. Okay? Next, what you did was you changed just the symbol, or you changed the order of the fractions, and you were able to make it true. What we're going to do now is you're going to work with your partner, and you're going to see if you can make the statement true in a different way, not just the symbol, but by changing one or both of the fractions to a different fraction. And what I want you and your partner to do is build a model to show a true statement by changing one of the numbers.
We could put 3/8 and 3/8 together to make 6/8. We could do 3/8 plus 3/8 equals 6/8, and then 6/8 is greater than 3/5.
Tell me what you changed and why you decided that.
We changed 3/8 to 6/8, and 6/8 is greater than 3/5.
Okay. You changed it to 6/8, so you doubled it. Looks like you doubled 3/8. And what can you tell me by showing your model that that is a true statement? What do you notice?
I noticed that 6/8 in here is greater than 3/5.
Okay, I can see it. It looks like that. You can tell, can't you? Okay.
What if we did, we took away 2 of the 1/5 and took away 1/8?
Okay. So now what would your statement say?
1/5 and 2/8.
Okay. And if you were using a greater than or less than symbol, right? Let's say you're using the greater than symbol like we did right here. What would your statement say?
2/8 are greater than 1/5.
Okay. Can you write that on your board? And maybe you can write true next to it.
We changed 3/8 into 6/8 because we did 3/8 plus 3/8 equals 6/8, and then we made 6/8 is greater than 3/5.
Okay. And how does the model help you?
It shows me by it says it's 3, and then this is 6, and then when you're here you can see that what one is bigger because they're all equal. They're like the same.
What do you mean they're the same?
Like if you do this,
Okay.
they're not all perfectly the same.
Okay.
But if you do that, they're all perfectly the same.
So I'm thinking what you're saying is that using the tiles is
Better than drawing a fraction.
because when you draw, what do you notice?
I know that they're not. I noticed that they're not the same thing.
Not exact, right?
Yeah.
You could be more precise, right?
Yeah.
Okay. All right. And over here, I see that you have your model and your statement. And can you tell how using the fraction tiles helped you decide how to change your fraction?
Did the time help us?
I think the is it true routine is a valuable routine in many respects because it's asking kids to think about mathematical statements and being able to discuss it with a classmate and being able to model it or draw a representation is a way that they can actually demonstrate what they understand. So it's to me it's a lot more critical thinking to think about whether something is true or false and how do you know? They have to prove their answer and show how they know.